Welcome to Clear Cove's revolutionary enhanced primary treatment technology. Over the next 10 minutes, we're going to explore how Clear Cove is radically changing not only new plant design, but also the retrofit of existing wastewater treatment plants. At a high level, there's a number of benefits provided with the Clear Cove technology. We're able to harvest 3 times the amount of energy compared to today's processes. On the secondary process, we're able to reduce those costs by 50%. We're able to do this at a capital cost lower than today's processes and technology, and we're able to double the capacity of a plant within the same footprint, ultimately resulting in cleaner water and the automation from start to finish from an operational perspective. Now let's take a look at the individual tank of the Clear Cove technology to see what actually goes on inside the tank. What we'll see initially is that the wastewater or influent enters from both sides of the tank into the grit section of what we call the influent feed system. We control all velocities coming into the tank, which creates the best design condition to remove the BOD solids. The influent feed system is bolted onto the face of either rectangular or circular tanks, creating a very modular approach when compared to common construction costs with concrete formwork. The flow and organic loading are controlled at all times by Clear Cove's SCADA control, allowing us to tailor the needs for each facility and also controlling the flow in and out of the Clear Cove system. As the influent enters into the IFS, the gross and dense solids and grilling of grit and solids. How we achieve that level is that the EPA recommends a rise rate of 0.16 feet per second, while Clear Cove achieves a 0.12 feet per second. We will show later in the process how these gross and dense solids will be moved to Clear Cove's proprietary sludge classifying press, extracting 100% of all hairs and fibers. Now the wastewater, minus the heavy solids and grit, weigh several 90-degree turns, which will help dissipate the pumping energy. As the IFS continues to fill, the surface area increases, further reducing the vertical rise rate, allowing medium density solids to settle out. The beauty of the IFS is that it replaces traditional grit and bar screen in the traditional process while providing in-vessel classification of solids. Now the wastewater, minus the heavy and medium density solids, makes one last 90-degree turn to further reduce the inertia in forward flow up and over the weir into the main chamber. With the addition of an optional bar rack, large floatables and rags are contained within the IFS to be simply removed and sent through the sludge classifying press and disposed of properly. Wastewater now flows over the weir at exactly 70-degree angle, promoting surface tension as well as cohesion and eliminating any chance of waterfall effect and air entrapment as a result. Now the densest, medium, and large solids remain in the IFS, while only the lightest, naturally buoyant organic solids enter into the main settling area. Now the wastewater continues to make its way towards the center of the tank from a balanced approach from either side. You can now observe that the gravitational acceleration of the influent down the declined face of the feed trough will scour the bottom of the tank and move the light, fluffy organics to the center. As these flows come together in the center of a tank, a resulting turbulence occurs, which is a great platform for mixing chemicals and solids while dissipating the horizontal velocities. One of the other features of the system is there's no mechanical equipment in contact with the wastewater at any time. Now as the liquid level rises above the weir, the vertical currents and velocities begin to dissipate as the liquid moves horizontally towards the center of the tank and the mass increases. This now begins a relatively undisturbed settling of the solids. You'll notice the rise rate is significantly reduced by the increased surface area of the tank itself. The rise rate is now 0.02 feet per second. By stopping this flow in the tank, we're allowing the settling of the light, fluffy organics. Now during this time, there is no liquid exiting the tank being filled. Conventional clarifiers have a continuous flow from the inlet to the effluent weirs. By stopping the velocity of the wastewater, this allows for the light, highly organic solid removal. Scum, oil, fats are removed from the surface of the water by raising the liquid level above the scum troughs at either end of the tank. Now as that trough collects floatables, a valve connecting that trough to the adjacent tank that has finished decanting, thus having a lower liquid level, is now open, allowing those floatables to be captured in a scum basket. The scum basket can be lined with a bag or simply emptied into a container for disposal after several days of collecting floatables. And finally, a simple flat valve is placed at the end to trap floatables in the basket. Now that the tank is filled, an optional settling period occurs tuned to the specific needs of each plant. The volume of the plant is based on the peak hourly projected volume for storm events, providing surplus volume for average daily flows, thus allowing a rest period. Now this settling period will be dependent on the rate of flow entering the facility as well as the desired level of BOD removal. This settling period will also allow for the high-value organic material to settle to the bottom of the tank where it will be removed. Now as settling continues, a stratification occurs in the tank with low, medium, and high BOD, with a concentration of the highest BOD at the bottom. Now let's move our attention to our screen box. The screen box is made up of 50 micron stainless steel screen. The system controls velocities at the screen liquid interface level, controlling and preventing the screen from fouling. As the screen box is decanted into the tank, an air scour turns on, deflecting fibers and fogs away from the screen. A backwashing also occurs. So the immediate benefit of the ClearCove system is that it removes all fouling fibers and solids, increasing the overall efficiency and life of the downstream process at the low BOD and TSS supernate level of the tank. Now the supernate, anything less than 50 microns, flows down the central hose and on no larger than 0.1, and also no fibers to the secondary process. This is achieved by lowering the decant box at the same rate as the liquid level, keeping the currents primarily horizontal. Now you can see that we've separated the tank into three areas. First, the gross solids and grit go to the sludge classifying press. The effluent goes to the secondary process, being reduced by 65%, and the light fluffy organics move on to the anaerobic digester. To characterize inherent benefits of ClearCove's EPT, we can reduce aeration energy consumption by up to 65%. We can increase the capacity. Has reached the end of its cycle. The IFS can now get rid of the gross and dense solids and move them on to ClearCove's proprietary sludge press. The feed troughs and grit box solids are flushed out periodically from fluid from the adjacent tank. When the IFS has completed its draining cycle, the high-value organics in the main chamber of the tank are now removed from the port at the bottom of the sludge hopper. Now all of those lightened for return to the biological nutrient removal process as a carbon source. The ClearCove EPT solution always will include 2 or more tanks and will size accordingly to the plant size. While one tank is filling, one tank is discharging. And this allows for enhanced settling to occur because one tank can settle as the other fills. As we move to the summary page of the ClearCove Enhanced Primary, how ClearCove is focusing on changing wastewater treatment now and in the future.